Hello class, this is Mr. Eggleston and this is lecture 6.2 or lesson 6.2, step functions for Algebra 1. The learning targets are to understand that step functions as a special type of piecewise functions where each piece of the graph is constant. And then also the second learning target is to interpret and graph scenarios that can be modeled with step functions. Basically, a step function would look something along the lines of, oh, that's fat. Something along the lines of this. Let's say we had this axis, right? We got our x and our y. A step function would be like this, where over these intervals of defined domains, I guess you could say, 1, 2, so forth, right? That it's constant, the output, the y value is constant from 0 to 1. At this value, you could be 1, let's say. Let's call this 2, and it goes back down to 1. So it's constant from 0 to 1 at 1, then jumps instantaneously up to 2 from 1 to 2, and then it drops again at 2 back down to 1. And it's called a step function because it looks like steps, right? Like you're walking up steps. So that's why it's called a step function. And that's it. So they do look a little crazy, and we're going to see this in this discussion on this activity. All right, so going down. Short-term parking at Gerald R. Ford International Airport is $3 for the first hour. Okay, is $3 for the first hour and $2 for each additional hour or fraction thereof. Now, if you even talk to your folks about this, they tell you this is how they usually charge. Now, why do you think about why they may charge you more, airport might charge more for the first hour than for additional hours. This really is just kind of a thought-provoking question. Think about it. Pause the video and write down what you think. All right. Well, I would say it's because there are people are dropping others off. People are dropping off passengers and will only stay for a short time. Will only stay for a short time. So they want to get money from you. So since probably the majority of people are like that, that's why they charge $3 instead of $2. Now, Mayo, which I thought was Mayo, but now as I look at it, is Moyo, parks his car for only 15 minutes. How much will he pay? Write down your answer. He will pay $3. Why? Because 15 minutes is less than 1 hour. Okay? So Tammy parks for 1 hour and 2 minutes. So she parked for 1 hour. Here's the second hour. So this was $3. Second hour is $2, but she's only 1 hour and 2 minutes, so she's really just sitting right here in this time interval. But still, she will pay 3 plus 2, which equals $5. And this is Tammy. Okay, I'll call it T. Javier, J, parks for 1 hour. So 1 hour. You see what I'm doing here? And then here's my second hour. Okay. We know that she pays $3, or he pays $3 for the first hour, but now he stays until 55 minutes, which is almost to the end. So he's here, but he's still in that 2 hour window. So he's going to pay also 3 plus 2, which is $5. Who pays more for parking? They pay the same. Okay, because they both stay longer than 1 hour, but less than 2 hours. Okay. Okay, now they're saying evaluate each of this, where C of H be the cost of parking. So they're asking you C of 0.5. All right, 0.5 is within that 1 hour, right? So that's $3. Okay. C of 2 is the first hour, which is $3, but then he goes into the second hour, which is $2. So C of 2 is going to be, C of 2 is going to equal $5. Okay, because again, you go, C of 2 is right at the 2 hour mark, and so he doesn't go more than 2 hours, which would bleed into a third hour. So it's just the first hour and the second hour. Now, 4.25 means he goes, here's his first, then he has his second, his third, his fourth, and his fifth. So he pays $3 here, $2, $2, $2. Now, if he had stopped at 4, he'd be right here. Oops, sorry. I hit the wrong button. Button. He would be, if he stopped at 4, he'd be, oh, wow. Did not expect that. He'd be right here. But he's at 4.25, which means he's into the fifth hour. So that's going to be 3 plus 2 plus 2 plus 2 plus 2. That's going to be 3 plus 2 times 1, 2, 3, 4. Why does it keep doing that? Sorry, it keeps jumping over and making it huge. And I don't understand why. Okay. So that's going to equal, 3 plus 2, and we got 1, 2, 3, 4. 3 times 2, or 3 plus 2 times 4, that's going to be $11. Okay. For C of 11, it's going to be the 3 for the first hour. And then we're going to have, for the 2nd through 11th, will be 2. So that'll be plus 2 times the 2nd through 11th would be 2 times 10. Because C11 means the first hour is 3, and then the 10 remaining hours is 2. So that's going to equal 3 plus 20, which is $23. It's not hard to do this, to calculate this. Now, I wanted to point out that notationally, we would say between 0 and 1 in this compound inequality. You need to understand this. This is, H is between 0 and 1. We have $3, okay? The cost is $3. From 1 to 2, the cost is $5. All right. Now they're saying graph C of H on the coordinate plane. Well, let's do this. I will use yellow because it's nice and bright. So it says for the first hour, here's 1, here's 3, here's 5, here's 7, here's, let's see, 1, 2, 1, 2, here's 9. All right. So for the first hour from 0 to 1, it's going to be $3. 1, 2, 3. So it'll be like this. Okay. Notice it's flat open circle, because think about it. If he doesn't spend any hours in there, he's not paying anything. So it's so we have a dot there. Now, all you gotta do, I'm gonna copy and paste this. Now, from 1 to 2, we go up $2, 1, 2, and you have that. And then from 2 to 3, we have that. Notice I'm jumping up $2. I'll explain why there's open circle and closed circles in a moment. Okay, we have this. Each time I'm jumping up 2. Okay. Each time, 1, 2. We do this. As I do this, all right, and then notice it changes here because it doesn't jump up to, and I'll explain why. It only jumps up 1, and this doesn't even end. It goes on forever, theoretically, until the next day. All right, but the reason it only jumps up 1 is because if you read this, there is a maximum of $20. So when you hit the $20 maximum, daily maximum, that's all you're going to pay for a given day. All right, so it looks like you're going to hit that in the 9th hour. So if you're going to stay like half a day or something, you'll pay $20 for that day. All right, they won't keep charging you. But there it is. It looks like a bunch of steps. Hence the name step function. Now, there's some things you got to pay attention to. Notice I have open and closed circles, right? I have an open circle on one end and a closed circle on the other. That is because on this step function, if you're exactly at 0, let's say, you're not going to pay any money. You're going to be down here. And we can't have two closed circles on top of each other because for this to be a function, you can only have one output. So you have to pay attention. This is key. One end is closed. That means it can equal that value at, let's say, 7. It's closed. So at 7, the output would be $15. At 7, cost equals $15. $15, not 5. Now, it's open on the other end here because we know at 6, he's not going to be paying $15. At 6, he's going to be paying $2 less, which is 12, 13, 14, Sorry, did I say 16? That's 15. So he's paying $2 less at 13. Okay. So you got to remember, one side's got to be open, the other side closed on this, because you can't have two closed points on top of each other, because that would imply it's not a function, because there's two different outputs for the same input. All right, so pay attention. That's a nuance thing that you got to pay attention to. Then, Cami gives the following equation for C of H. Do you agree or disagree? Explain. Pause the video and think about it and see if you can come up with you saying you agree or that you disagree. All right? Okay. Well, I would say, quite honestly, that I disagree. Okay? That is... if it's 3h and its h is between 0 and 1, if you went half an hour, according to this model, you would have 3 times 0.5, which is $1.50. But we know that for the first hour, any fraction thereof, you're going to be charged $3. It doesn't give not the right output. Okay. So I disagree. It doesn't work. Okay. So here we go. The step functions, learning target number 1 is that step functions type of piecewise defined function where the pieces are constants. That's why they're flat lines, because it's constant. It doesn't change over this interval. All right? Often used when you can't have part of something, i.e. the parking situation, because that is truly something as an adult you're going to be dealing with. All right? Learning target number 2, the graph. Open circle point not included. Closed circle point is included. All right, so and they look like little steps. That's why this is called a step. This is oh, wow. Woohoo. This is a step each time. Okay. So go ahead, and that's it for this, and try to check your understanding and come back to see what the solutions are.